There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and solarium, and bismuth, lithium, beryllium, and barium. Isn't that interesting? I hope you're all paying attention. There's going to be a short quiz later on. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury and molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radenzine, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Okay, look into the camera. Now look, we're going to do a little demonstration today involving sodium acetate. In this packet is sodium acetate dissolved in water, but it was heated up to a point where it all dissolved. And I'm going to ask my grandson here, well, actually, Hi Guy Pepin, to take this little thing to get it to initiate. So will you do that, Pie Guy Pepin?
Okay.
Click it. And tell me.
Click it.
Just that's it. You do
there it is.
All right, now feel what's happening. Let's show the audience.
God.
See how it's getting hot?
They can't see that.
Oh, it's very hot. So the process of the solution changing to the solid is exothermic, gives off heat. Okay, and in the next part of this video, okay, we're going to do another one, and we're going to do it by measuring the temperature as we do it. All right, so let's get started on that. All right, so it went from a liquid, a solution, to a solid. Now, if I heat this up again to a high temperature above about boiling, and then it will dissolve again, and then let it cool slowly and without any agitation. It will super cool, and then eventually, if we agitate it, it will give off heat and turn to a solid. It's very hot. If you hold it tight, it's almost a little painful to feel. All right, well, we'll show you that with. Okay, everybody, we're going to now do a temperature time study of this reaction of the sodium acetate. So we're going to start collecting data. All right, now I don't want it's at room temperature, so I want to be able to measure the temperature of it, but I want to get a baseline first. Okay.
He wants to get a baseline first.
Can you see around below 30, it's about 27 degrees.
It's right here.
All right, move it out of the way. Okay, now let's let it form a baseline for a few minutes. All right. Give me a chance here. I'm going to put it, okay, I got it encapsulated, all right? And now, let's let it go just another minute. And I'm going to cause it to click. Okay, good. All right, let's see what happens. You can see I can feel it hot in my hand. Takes a little while for the temperature to dissipate. Oh, look at it go. Look at it go. That's what it is. All right.
Okay, so now we'll
All right,
go back to the being sped up and all.
So now.
Now you can finally watch my
All right,
You see what happens when you pop a defective.
Okay, start.
See what happens when you pop a defective. Oh, it's popped, it's getting hot, it's getting hot, it's getting hot.
Be careful. I don't want to break it.
Ta-da! That's what happens when you pop a defective one.
Okay.
And
All
now
right.
it's really hot.